Good morning. My name is Beth Capellas, and I'm the marketing manager here at Triangle Microworks. I'd like to welcome everyone to our latest webinar, Strategies for Upgrading to IEC 61850, Edition 2.1, Learn how to prepare and test. Before we get started, I'd like to go over some housekeeping items while everyone is still joining. The webinar is scheduled to be 1 hour long. We will take a couple of breaks throughout the webinar to answer some questions. The audience is on mute due to the large size, so please submit your questions online using the webinar toolbar under the section titled Questions. You can submit questions as soon as you have them. Don't feel that you have to wait until the end. We will begin answering questions online as we have several engineers monitoring the questions and responding to them directly to you. We will read and answer some of those questions at the breaks, and then we will take some time in the end to go over any remaining questions. Before we get started, I would like to introduce the folks that are behind the scenes actually answering those questions. Today we have with us Jim Coates, who's the president of Triangle Microworks. We have Dave Gokenauer, our senior developer for Distributed Test Manager, one of the tools that we'll be seeing today. Eric Fabre, our senior QA tester. And we also have Sri Angela, our senior developer for Test Suite Pro, another tool that we'll be touching on today. Next, I would like to introduce our main speaker, Joel Green from Triangle Microworks. Joel has worked with communication protocols for over 15 years, with the last 6 years on a focus in the power industry. He is the lead engineer for IEC 61850 product development at Triangle Microworks and is heavily involved with 61850 industry groups. He also works as the co-editor of IEC 61850 7-2. He's a member of the UCA Test Committee and Test Procedure Working Group and is heavily involved in the IEEE Standards Association. So with that, I'd like to go ahead and hand it over to Joel to get started for today.
Thanks, Beth. Good morning, good afternoon, good evening, everyone. Thanks for joining us today. We're going to talk a little bit about the new amendments to 61850 that have been published in the last year or so and go into how those might affect your systems and work and how to plan for that. First of all, a little bit of background on Triangle Microworks. We've been around for a little over 25 years now. We're based in Raleigh, North Carolina. And we serve a number of folks in this industry, primarily equipment manufacturers, but also end users, utilities, and system integrators. Serve all those worldwide. We build products based on open standards published by a number of different groups. In this case, we're focused on IEC 61850, which I'm heavily involved in, but we also support DNP, OPC, Modbus, IEEE, and the UCA users group to support testing in 61850. Because of our heavy involvement in all these groups, we're able to represent any interests our customers have and contribute to forward development of the standards. We've got a couple of different product lines. Our core business is the source code libraries. This is the basis of the protocols we work on. We provide those in ANSI C, C++, and .NET interfaces. Allow easier implementation so that vendors and tool developers can focus on their value add, not have to learn all those details. On top of those source code libraries, we've built a set of test tools for implementations of these libraries, originally focused at the device vendors that were incorporating our libraries into those tools, but we've expanded on that expertise to build system test tools, help the end users understand the protocols and test their communications without having to know all the intricate details. In addition to that, we have a protocol gateway that will allow translation between all of the various protocols that we support. Today's webinar is following up on one we participated in July on behalf of UCA International Users Group. When 61850 Edition 2 was published, approximately 2010, so quite a while now, that was a pretty major jump from Edition 1 to Edition 2, and it caused there were a few backwards compatibility issues that caused a lot of uncertainty in the market and delayed a lot of adoption of those new features. So when the working group went to release these amendments, we went to a great deal of effort to make sure that we didn't repeat that mistake, I'll say. A lot of careful analysis went into any compatibility issues moving forward with the amendment, not only within the working group, but also UCA. UCA has two major missions. They provide conformance testing, certification, verification for 61850. They certify the test labs that do conformance testing of 61850 products. And also as a users group, of course, they have an objective to provide guidance to users on the standard. So UCA produced a white paper. If you're a member of UCA, it's available on the website. After thorough analysis by quite a number of experts who went through and verified all the changes in this amendment and have consolidated guidance on the issues that need to be considered moving forward with the standard. So UCA participated in that webinar, produced that webinar, gave a lot of advice on how that works and also the updates to the testing procedure involved there. We've adjusted the quality assurance program with UCA to be sure that the life cycle of devices is still in place, that existing systems can continue to be maintained. Yet the testing procedure is going to evolve to no longer certify edition 2.0 devices only, because it's important to the industry to move forward and adopt new improvements to the standard. Also with that webinar, we had participation by D&B GL. D&B is the oldest test house doing conformance testing for 61850. They formerly known as KEMA, a lot of expertise in that group to guide vendors through the conformance test process. So they gave us an in-depth overview of what those changes are in the coming test procedures updates. Red Electrica is a utility in Spain. One of my colleagues there joined us to give the utility perspective. Updates such as this always carry some risk that has to be carefully analyzed. So those guys did a very thorough analysis of the changes and what the risks are and what the benefits are of updating to the standard. And their conclusion, the overall message they brought was updating to Amendment 1 is a when, not an if. There's no question that it needs to be done, that systems need to move forward. But the planning needs to be in place. It needs to be done carefully, make sure the few things that need to be checked are checked, and those plans are rolled out in a methodical manner. And then Triangle Microworks presented some guidance on adoption strategies, and we're going to go into that a little bit more and show how to test really one place that you need to be careful in updating to edition 1, and how to mitigate your risks and make sure whether or not there's anything you need to be concerned about in your current systems. So the Amendment 1 IEC process, the documents are all maintained individually. So when we're talking about the Amendment 1 here, we're really talking about updates to the handful of core parts of the standard. There's some 50 different 61850 documents in production, in publication now. And each of them is actually independent, but the core group is generally maintained together. So when we say Amendment 1, we're talking about updates to the core parts. Part 6, which is the description of the system configuration language, the XML format that describes the 61850 systems. Part 7.2 is the abstract communications interface. This describes the abstract services, read, write, data sets, all that. Part 7.3 describes the common data classes for 61850. These are the basic data objects that make up the model. 7.4 gives us the description of the logical nodes in 61850, which are the collections of data objects from 7.3. And these are the basic functional building blocks. These are minimum sets of function in 61850. And then 8.1 is the concrete mapping in this case to MMS. So we take the communications abstract services in 7.2 and map them to a wireline protocol. I think it's the same one. So all of these documents were published approximately 2010. They've been in the field for quite a while. They've got plenty of miles on them. They're well exercised at this point. And they've been updated a bit over this 10-year period. The IEC process prior to 61850, the standards documents were delivered in PDF. They were updated on a process developed in the paper world where standards were produced and distributed in paper format and then later in PDF. 61850 was a huge effort to modernize communications protocols and move us into the digital substation world. And as that was started with edition 1, originally 61850, some 25 years ago, it was identified that we needed a faster process to handle essentially errata in the standards. So 61850 defined what was called a tissue process. This is technical issues. And that tissue process we're still using with some updates today. That allows us to respond to any issues in the standard. When we find a place where there's an ambiguity in the standard, where two vendors don't come to the same understanding of how to read the standard, we can, at a reasonable pace, identify the issue, propose solutions, push and publish that. There's an online database that collects all these. Those get fed into the UCA test procedure process. Manufacturers know what they have to do to produce a device to the current standard. So edition 2 has evolved over the last 10 years through this errata process that allows us to respond to those issues relatively quickly. So the vast majority of the Amendment 1 of these parts is the collection of those tissues so that we have a consolidated document of all the changes that have been made throughout this life cycle. The vast majority of changes in Amendment 1 have been in the field for years. But at a certain point, we need to collect those into a single document and ease the maintenance cycle of checking through the database. In addition to collecting those corrections throughout the years, we do have a few other new concepts in the amendments. One of the main ones is routable GOOSE and sample values. The IEC process, or the IEC process to generate standards, has a mechanism called a technical report. The technical report allows us to propose a suggestion on how to solve a new problem. What we have in routable GOOSE and sample values, 61850 was designed from the perspective of the substation. In edition 1, it was communications for substations and substation configuration language. And the perspective was, we're inside a fence, we're inside a fixed network. That's a closed system. And so we implemented GOOSE and sample values with layer 2 Ethernet multicast. Layer 2 Ethernet multicast will go to every device within a subnet, but it will not cross routers and switches. It's not routable. And that was fine in the substation world. Well, in the last 10 or 15 years, 61850 has expanded outside the substation. In fact, edition 2 changed the entire name of the standard series from substation to system, acknowledging that we're having broader scope, particularly in the distributed energy resources world. The ER world is much more dynamic, much more distributed, as the name says. So we need to be able to reach these systems outside the substation. One of the major drivers for this was synchrophaser devices between different utilities, between different grids. There was a major outage in New England in the United States in the early 2000s that turned out to be caused by lack of synchrophaser information exchange. And so routable GOOSE and sample values was produced to do that. move the functionality of GOOSE and sample values as it always was, but wrapping it in a UDP multicast frame so that we can route that. And that's been published for 6 or 7 years now. It's been tested in the field. It's been updated. A few problems were solved. The beta tested, if you will, and proven out. And now Amendment 1 incorporates the information. TR 90-5 is, there's some good use case and background information in there, but as far as the implementation, that's deprecated at this point, and we've absorbed those definitions into the core parts of the standard, specifically 8.1 and 9.2. So that's the maintenance life cycle. We've pulled in those changes that came from that technical report format instead of from a tissue process issue. We also did a lot of updating to the models behind the scenes. We've gone to a UML model generation format. This is entirely invisible to the user. This is entirely a document maintenance thing, so nothing any user will ever know about, but it helps us validate the models before we produce the documents and the schemas in 61850. Another big chunk of work that got added with the amendment were compatibility rules. As I mentioned, we had a huge issue with some backwards compatibility changes throughout edition 1. A lot of uncertainty in the market, and so the working group went to a great deal of effort, detail, to analyze any possible issues with compatibility as we move forward, not only to Amendment 1, but to Edition 3 and other updates of the standard. And the various documents have these published. The beginning is 7.1. So 7.1 gives an overview of the 61850 standard. And that gives us a overview of the compatibility rules, how they all fit together. And then each part includes an annex that describes how the compatibility rules apply to that particular part. And we'll go in through the compatibility rules in just a minute here. First, let's see if we have any questions at this point.
We do have a couple that came in. First question, where can the tissue file be found for reference purposes?
The tissue database is available online. If you Google 61850 tissues, you'll find the web page immediately. And it's, I believe it's tissuedb.61850.com or something along those lines, but Google 61850 tissues will bring you right there.
Okay. And I have one additional question. Can we get NW and VAR signals in GOOSE protocol to SCADA, which supports 61850? And it has in parentheses SCADA client and IED server.
I'm going to say yes. I think we're talking about sending analog values from 61850 servers to essentially the HMI and control center.
Mm-hmm.
If I understand the question, then absolutely that's a normal feature of the protocol.
Well, and if you want to, the person that sent that question, feel free to send in some follow-up details and we can address it later on in another question and answer session if that didn't answer it for you.
Definitely. Anything more specific there we can go into?
Mm-hmm. Okay, and then if you want, Joel, you can go ahead and move on.
Okay. So we're going into a little bit about the specifics of the compatibility rules. As I mentioned, 7.1 gives in great detail the concepts of the compatibility rules, the overview of how they work, and what the reasons for each of the possibilities of changing the standard are. For the most part, we can We fix errors, we add enhancements, we make clarifications. The majority of the time, we're adding additional functionality that won't change anything in existing systems. Old devices simply can't understand the new functionality, but it doesn't create any impact on the existing functionality, and that's all okay. So 7.1 gives us the overview of what those rules need to look like. This is a snippet from 7.4. As I mentioned, the collection of logical nodes from the standard gives us the basis of the modeling. And so this lists how each rule from 7.1 applies to that part of the standard. And it goes through and tells us every case in this document, in this amendment, where that rule is applied and what the changes are. So we've got a snippet here showing you a little list. Here we've got new data objects based on a new common data class added to existing LNs. So this is a list of the ANCR added a call change and so on. So we've got an explicit list of everything that changed in the standard. Again, the majority of these are modeling changes that are going to have no impact. They're going to be additional things added to new models, completely interoperable with anything in the field now. The other major chunk of this work in the compatibility issues is not how the standard evolves, but how devices need to behave in order to guarantee forward compatibility. And this is one excerpt from 7.1. There's quite a few of these tables. There's one for every one of those rules listed. And what this talks about is for the device vendor, the tool vendor, how do I need to program my product in order to not have any problems in the future when the standards evolved. And as you can see, this goes through each type of device in the system and talks about the impact and the recommendations on it. So in this case, we're, like the last example, we're adding a new data object based on a new CDC. So for instance, 7.4 is updated. An existing LN adds a new data object from a new CDC in 7.3. If I'm building a device, in order to be sure that I don't have a problem with this situation when the next update to 61850 comes out, if I'm a client, this is achievable. As long as I can use the get data definition, which is one of the discovery services in 61850, I can go ask the server what it provides, or I can read the SCL file and interpret the data type templates from the SCL file, and I can learn what that CDC looks like, and I can work with that. As a client, that's all the information I need to be able to understand the model that's out there. If the data object itself is something I don't know what to do with, my client application doesn't need it anyway, it's not a problem. But my forward compatibility is achievable here. There's nothing that will prevent me from working with a system that makes this change, or device that makes this change. Similarly with the subscriber, forward compatibility is achievable. I have a mechanism, I can analyze the data structure. I can see the data set members. I can see the list either by interrogating the device or by reading the SCL file. I can get access to the data type templates. I can understand the structure of the CDC. I know the data types of each member of the CDC. I can achieve forward compatibility if I design my product understanding that I may have to interpret these things in a newer edition. We also list here backwards compatibility. In this case, backwards compatibility is guaranteed. There's no possibility of changing anything in this direction that would break existing systems. If I'm the IED tool, so each IED in the 61850 system has a configuration tool and then access. It interprets the SCD file, configures the device. Again, essentially the same situation. Forward compatibility is achievable as long as I design my tool to understand the possibility that comes here. So in this case, we may have to be able to ignore a DO that we don't understand. That's fine as long as my device is capable of ignoring a configuration it doesn't understand. We can achieve that forward compatibility. Again, backwards compatibility guaranteed in this case. At a system tool level, there's no problem in either direction. The system tool has to understand everything that every device in the system can do. This compatibility is guaranteed in both directions. And then for downgrading, downgrading is a concept where a system configuration tool can put out an SCD file at an older revision. So in some cases, if I'm moving a system to, for instance, 2.1, and I've still got, for example, edition 1 devices in the field, and I'm trying to use those devices in my updated system, that device that's been sitting there for 20 years is never going to be able to understand a 2.1 SCL file. The schema's changed, et cetera, et cetera. So the SCT will produce, based on the rules, these compatibility rules, the SCT can produce an edition 1 SCD file that describes the information that those devices need to interoperate in this system. Now that means that the GOOSE messages that that device publishes and subscribes are limited to the set that the older revision can understand, but the system tool knows those rules, knows how to do that, can make that all interoperable.
Okay, are you ready for a couple more questions?
We have some there. I think we went into a little bit more detail in the standard. So see if we have any more detailed questions there.
I do have a couple of questions. So the first one, which part of the 62050 standard would be a starting point to understand the differences between edition 1 to 2 and 2.1? And the kind of follow questions at any specific sequence of 62050 standard part numbers.
So the place I would recommend to start there is 7.1. 7.1 gives a lot of the background and overall concepts of 61850. And that annex in 7.1 is the sort of the root of the compatibility rules. Every one of the core parts has an annex that tells how the 7.1 rules apply to that part, but 7.1 is the background concepts for all of that. The other part that has a lot of information on how to put all this together is part 6. Part 6 describes the system configuration language, which in one sense is the syntax of the SCL files themselves, but there's also a lot of background information in there on the system engineering process, which did get some clarifications with this amendment. So there's a lot in there about how the file types work and how the round trip engineering process works, how all those pieces fit together, including some forwards and backwards compatibility information. Okay. Additionally, as I mentioned, the UCA white paper goes through some of those details as well.
Okay. Next question, like the list of data model changes listed in the annex of 7-4, is there any document which lists out the exact feature-wise changes from edition 2 to 2.1?
So the exact changes are produced in documents in the document that's called the amendment. The IEC produces 2 different documents when there's an amendment. The amendment document itself is literally the change set. It's the diff between the old document and the new document, and it's very painful to read, but it explicitly lists the changes. And then IEC produces what's called the consolidated version, which is the document with the changes applied. So it is the new standard, although technically the amendment is the normative version. The CSV, the consolidated version, is if there's any error between the two, the amendment's actually the truth. But it's impossible to use, so we have the consolidated version. But the amendment document itself is an explicit list of the changes.
Okay. We do still have a number of questions coming in, so I want to encourage those to still come in. We will try to answer them online, but Joel, go ahead and continue on so we can just stay on schedule, and then we will get back to answering some questions and answers live.
Okay, so we're going to go through quickly our 61852 toolkit. I'm going to go through at a high level some of the overall features of two of the tools that we're going to use to show some of this testing and how you can examine your systems and make sure everything's as needed. First of all, we have Test Suite Pro, which is our diagnostic test client. And this is a tool designed to analyze originally devices built with our stack, but now more 61850 systems, substations, all that. So we'll go through a little bit about how to investigate your systems and how to be sure everything's working correctly. And then we'll look quickly at Distributed Test Manager. Distributed Test Manager is our system simulation tool. It can simulate not only 61850 devices, but all the other protocols we do, DNP 870, Modbus, TASI2. With 61850, we'll import the SCL file and be able to generate a simulation from that. And we also have SCL Navigator. We won't look at that today, but that's an ICD editor and SCL verification tool. So I think we've gone through a couple of rounds of questions. We're going to go on into the quick overview of the tools here. So this is the Test Suite Pro. This is our diagnostic client tool. It's got a number of things here to let us analyze our system. At the moment, we've got DTM running in the background. We're analyzing. We'll show you DTM in just a moment. We'll go through the highlights of this tool quickly. On the left side of this tool, we have a set of tools. To begin with, we have system status. And the system status is showing that we're connected to 19 IEDs in this case. It just shows us that a high-level view that everything's happy, addresses and so forth. We've got another set of tools here. And you can see on this side, we've got a red light, green light thing that the green check says everything's happy. This tells us we've got an issue here somewhere. So I can come into this file, and what I can do with this compare model is lets me discover the IED and compare it to the SCL file I've got. If we have a mismatch between client and server SCL files in the field, that can cause a lot of problems. It can be very expensive to track down. So this lets us go and very quickly see if the device we're hooked to matches what we expect it to be. And lots of green here, everything's good. And no problems. If I found anything here that was different online from what I expect, I would see a list. I don't. Goose Tracker allows us to monitor all the goose on the wire. This is sniffing the wire, checking the goose that we see on the wire versus the SCD file we loaded. In this case, I've missed a couple of retransmissions on the wire, so I've got warnings about that. Otherwise, we're very happy. If I had any goose on the wire that I didn't expect from the SCD file, those would show up here, show an error. If I had anything in the SCL file that did not show up on the wire, I would see that as a warning as well. Additionally, monitoring goose traffic, we have an LGOS monitor. LGOS is a logical node that a subscriber can provide to give an indication, supervision of that LGOS stream. And so this matrix here is telling us which servers and subscribers are in the network and which of the subscribers provide LGOS nodes. And if it has an LGOS node, whether it's happy or not. In this case, we're running the simulation here in our local device. in our PC, there's no problems going on. And every case that I have, a publisher and subscriber gives me that indication. In this case, this device over here, test subscriber, does not provide LGOS functionality. That's optional in the standard. So this red is telling me that I don't know what this device is doing because he won't tell me. And there's a whole lot of other statuses available that can tell me a lot about what's going on in the system. But that gives me a quick overview. If my devices aren't getting the signals they need, my system's not going to work. So that's a pretty high level check. And I've got warnings here, these ones that don't provide LGOSs. And then my high level indicator here gives me a summary of how many issues I might have. Similar to that, I can monitor the mode and behavior and simulation status. These are test features in 61850. When I'm testing a system, it's important to understand how each of my devices are configured with respect to these test setups. So this matrix gives us a quick overview of what those look like. We've got a STL verifier. We won't go over that today. Data miner is a way to create these displays on the right-hand side that we'll go to. Helps me find stuff in the model. And then we have an advanced client. The reference here is the advanced user. This is a very raw interface. I can get to the server and have almost no limitation of what I'm allowed to do here. For testing purposes, I've got a set of negative tests I can run against the device. I intentionally let you do bad things if necessary for testing. And a couple other particular tools here for testing particular services. When servers being implemented, all those need to be tested. And then we have a GOOSE publisher. 61850 provides for simulated GOOSE and sample value messages. This replaces jumper wires and test boxes to inject signals in the old copper wire substations. The GOOSE pub can publish messages with a simulated flag. And from the test tool, I can manipulate the data set members and the headers of all these in order to create tests. On the left-hand side here, I've got a series of displays. This is a custom display. This allows you to quickly build an HMI for various testing reasons. All these signals here are live. This is showing me the status of my simulator. And this is all live data coming in here. So I can drag objects from the model and set up this display. See what I need to see quickly for any test I need. And I can keep a number of these displays in the list. We've got a logic analyzer. This allows us to monitor the signals on the wire and plot those in a pretty typical logical analyzer format. We've monitored a successful reclose sequence here, and we're able to display that. In a similar way, we've got signal flow. This monitors the same signal instead of a time graph. This is an animation. It allows us to show all these signals. The yellow lines will show the sequence of events as we step through. And light that up, make it easy to visualize what's going on in our system. And we likewise have GOOSE and report viewers over here that we can see the messages on the wire. So that's a high-level overview of Test Suite Pro. We'll go look now at our distributed test manager that this is connected to. This is our server simulator. And this tool allows us to simulate any system, any number of devices out there quickly and easily. We see here a one-line diagram that's tied to all the devices in this system. So we're simulating all these IDs. We've got a list over here. This is our workspace on the left-hand side. It identifies all the resources in this workspace configuration. On the bottom here, we've got the list of IEDs. And these are all the servers that we're simulating. Test Suite Pro had the list of those in the other display. To set this up, we load IEDs from an STL file. For other protocols, we can do it from a spreadsheet and a list, or we can add them manually. One of the features that we have here, if we're trying to test a device, we can set up the whole system And if I'm trying to test my particular device, once I have the system proven in simulation, I can come in here and disable one device and bring my hardware in and test that hardware against the rest of the system. So in order to test communications, we need to be able to manipulate data in the model. So we've got a number of features here to be able to simulate data in the model. To begin with, we've got a manual change. I can come in here in any one of these. I can show the data model. And I can open this up and I can come click through the model. And then I can change any of the data in here manually if I have specific things I need to test. It's pretty slow going, so we have some automated ways to test data. We have an auto data change node here. This generates a list of changes, and I can come in here and set this up with a periodic timer and a function to change the data, particularly for analog values. I can change the ramps and all that. And I can set this thing up and tell it to go change that data by whatever format I need for my test. In addition to that, if I need a more specific way to change data, if I want to be able to reproduce a particular sequence of events or series of events, I can drive those data changes from a spreadsheet, a comma separated value list. And that looks a lot like this. I've just got a simple spreadsheet. I've got a column of paths, and my rows are states. So each of these states exists here. And at this state, the value for each attribute in our list is here. I can apply that. I can have it run through and change that. I have a method here where I can start that up and step through the particular states. So I have a list here of the states from the columns in here, and I can set every device in the system to that state with one click. In addition to that one click there, I can also manipulate the states from this table based on scripts. We have a script engine in here right now that is based on JavaScript. We can JavaScript, we've got a simple script here. The JavaScript editor's in here, and we can program just about anything behind the scene, behind the model here. This is just a simple script that changes a value in there. But this has, the JavaScript has full access to all the data model behind DTM. So we can, anything that needs to be done can be scripted there, including referencing those states from the CSV files. In our upcoming release, we're adding to the JavaScript the ability to use 61.131, so that's structured text from the PLC world. So if you've got programmable devices in your systems that use structured text for their configuration, that structured text can be directly imported into DTM. And we can simulate the exact same logic from the definition of those devices. Another test we're going to show quickly is our test manager. We can run lists of tests that allow for repeating specific tests. We can set up conditions and tests here and quickly run through each of these tests. One of the particular functions that DTM is useful for is gateway testing. Because we implement all the various protocols that we support in here, a gateway typically needs to be configured and tested. If it's, for example, you've got DNP outstations in the substation, and we need to get that data up to a 61850 client, an HMI in the control center, we have a gateway that has to be configured to map the DNP points into the 61850 model. That's typically a lot of a lot of manual labor to test all that. Since we have that mapping information known, DTM can simulate the IEDs in the field, manipulate data changes there, simulate the client at the control center, and programmatically verify that the correct changes are recorded on both sides and test the gateway configuration very quickly. So that's a high-level view of the two tools.
Okay, Joel, did you want to take a couple of questions, or are you going to go on to the?
Yep. Do we have any questions on the tools there before we go on?
We do have a couple that are coming in. How many IEDs can you simulate at one time?
That is a resource and licensing question. I believe I did fail to mention that DTM is called Distributed Test Manager because it can distribute the application over multiple PCs and test across networks. It is licensed in numbers of connections, but those are the only constraints with the licensing, and with enough PCs, we don't really have a hard limit of what can be done there. The system does scale as needed.
Mm-hmm. And I'll just add that question was answered online by Dave. So his additional response was, we routinely simulate hundreds of IEDs depending on the IED and the hardware, as you mentioned, Joel. And we have simulated as many as thousands of IEDs. Next question. Can you show the remote control commands from an HMI? I assume that's referring to DTM.
I'm sorry, can you
show the remote control commands from an HMI?
If we're using DTM to test an HMI, if the HMI is issuing commands to the simulated server in DTM, we would be able to see that in the logs in DTM, as well as reports in GOOSE of the effects of that. I hope that was the question.
Yep, and if that does not answer your question, whoever did submit that, please feel free to send in some follow-up information or questions, and we could address it at the end. And I think, Joel, with time in mind, go ahead and continue, and we can get to these questions towards the end.
Yep, very good. So getting into how do we move forward with adopting the amendment. As I mentioned earlier, UCA and the working group and many experts have analyzed this in great detail. We're confident that there's very little concern here. But at a high level, there's a few different situations where we could be needing to implement Edition 2.1. The first of which is a greenfield. We're building an entirely new substation. In this case, there's nothing to worry about. You want to implement the latest and greatest. There's no compatibility issues at all because it's all new. Away we go, nothing to worry about there at all. The second situation we have is an existing system that meets all the user requirements. We've got a 2.0 system or even an Edition 1 system in the field, and then everything's working and nothing new is needed. There's no problem there. As I mentioned, the UCA has updated the conformance test procedures, the quality assurance program behind the conformance test procedures. We will be end-of-lifing Edition 2.0 testing. It is important to the industry to move forward as the standard advances. So it's a couple years out, but we will be end-of-lifing Edition 2.0 only testing. We've already end-of-lifed Edition 1 testing, 10 years too late, but we got it done. However, we need to separate in concept the conformance testing from the life cycle management of these devices. If you've got a 2.0 system in the field, your vendor's not going to be, in a couple more years, not going to be able to produce a new product tested only to 2.0 systems. He will, however, be able to continue to sell you replacements for the devices you have now for as long as he cares to maintain that life cycle. So that's a huge distinction between end-of-lifing testing of new devices and availability of replacements on the market. So there's no risk to ongoing maintenance of existing systems. So in that case, everything's fine. There's nothing to worry about. We can continue to maintain existing systems throughout the life cycle of that system, no change. Where it gets interesting is where we have a mixed system. We've got a substation in the field. We need to expand it. We need some newer functionality. We want to get up to date. We want to take advantage of some of these improvements. And so we end up needing to expand the system with what's on the market now. We've got a couple of options here. We can always add devices at the same revision as the existing system. As I just mentioned, the vendors can continue to produce the devices that are on the market today for as long as they care to do that. The other thing that we've added in the quality assurance plan with the UCA is the ability to certify devices for older revisions. We're going to end of life edition 2.0 testing a couple more years out. I believe it's 2023, but somewhere in that time frame. However, after that point, a new device coming in for conformance testing, once it's been conformance tested to the current standard, because the IEC has one standard at any particular time, edition 2 now includes the amendments. That's, according to the IEC, the only version of the standard. Once we've conformance tested the device to the current standard, we can then, if the market demands, certify that same device to be configured in a compatibility mode so that it can behave exactly like a 2.0 server. So there is a forward path. If the market needs those devices and the vendors see the value in producing them, we will certify new devices to meet both versions of the standard going forward. So there is a path to provide updated devices continually. The other option we have at this point is to add 2.1 devices. So this is where we get into the mixed system. And the concept in 61850 is if we have mixed systems, the SCTs, the system configuration tools, and the clients need to be able to understand all the devices in the system. Servers only have to deal with one other device. They only have to understand their rev level, but clients and system tools need to understand them all. And we've gone through and we've investigated all the possibilities with Amendment 1. And really the one issue that's come into play is we made a breaking change in reservation of control blocks. Reservation's been in the standard since late in edition 1. It's been there a long time, but it was optional on the server. We've gone and made it mandatory with this amendment. It should have always been. Lots of history, but it's obvious that had to be. We went ahead and did it, acknowledging there's a backwards compatibility issue. Edition 2 clients should have always implemented the reservation services, but because it was optional in the server, there's some fear that some clients may not have realized they needed to do that. And so we need to test that scenario. If the client, with your HMI, your gateway, does not properly do the reservation scheme, then it will need to be updated. And so we produced a simple tool to test for that scenario. And we're back to our distributed test manager, which doesn't want to move to the other screen at the moment, but we're going to convince it to. There we go. So you can download this from our website. We've got a workspace here that allows us to test your system. So what you will do is bring your system configuration description file, your SCD file, into 61850. simulate one or more of the servers in it, and then have your client connect to it and attempt to enable the report control blocks. So I've loaded this workspace. It's on the start page in 6150, one click under the short list of workspaces there. And from here, we've got some basic instructions. We're going to come in here and we're going to load a file. So I'm going to go manage, add 6150 servers. And I'm going to go find my SCL file, import my configuration. And this is an SCD file I'm using here. DTM allows me to monitor external files for changes. I'm going to say yes. Go through that. At this point, I'm picking an IED. I can reassign my IP address. This red here is telling me that IP address doesn't exist on my PC. There we go. And I can simulate that device. So DTM's going to load that up. It's waiting for it to come online. And there it is. Our server's up and running. Our workspace here is telling me I've got one server. I could have loaded many servers out of that file. I've just got the one. My one server has a whopping 216 report control blocks. I think we can find one to test out of all that. Nothing's enabled. So at this point, you're going to bring up your client, your HMI or your gateway. My client happens to be Test Suite Pro again. And with Test Suite Pro, I can come to my advanced client. This is that raw interface we discussed. And what I'm going to do is discover this device. I could load my SCD file in here, but in this case, I'm just going to go query the server and find out what's out there. It's on my same PC, so I'm just looking at the loopback address here. And we'll go out and find our device. So we found all that, and we're back here. We're going to go into one of our devices. I'm going to find my report control blocks. I'm going to find one of them. And the reservation system is it's a mutex. It allows a client to claim that control block and then configure it and then enable it so that it claims the control block for itself and prevents anyone else from using it. So if I come in here and I say enable a report control block, my workspace in DTM is going to say it didn't get reserved. We're looking at an edition 2 server in this case because the majority of the files around edition 2 server would let me enable that. So I'm explicitly saying here that it didn't reserve it. And I can see here that it's enabled. So if this is the result that comes out from your client trying to enable a report control block, it's not going to work with an edition 2.1 server and needs to be updated. On the other hand, if I come in here, leave that there and start another one. So reserved TMS is the time in seconds that this control block is reserved to my client after I disconnect. So I'm writing that. And we see over here in DTM that the control block was reserved. And now I can enable it. And it's successfully enabled and everything's happy. My client behaves like that, I'll have no trouble with edition 2.1 at all. So it's pretty much that simple to verify that your system's ready for 2.1. As I mentioned, this tool can be downloaded from our website. And I think I have run the clock out, have I not, Beth?
We are right at the hour, except your
Okay.
final demo.
Yep, we're happy to stick around a few minutes if there are more questions, but I think we're.
We do have a couple more questions. So let me just kind of wrap up here. Again, we are at the hour. We're happy to stay on, whoever would like to stay on with us. Just so everyone knows, this webinar will be posted on our website in the next couple of days. Once you sign off from here, you will also receive a survey. We would love to get your feedback on what you thought of the webinar, if you'd like additional information on what you saw today. And of course, to answer any other questions that perhaps we didn't get to address during this hour. And you can certainly download any evaluation licenses of the tools that you saw here today. That workspace is available in DTM that Joel just showed you. And of course, I've left my contact email address there on the bottom of the slide if you want to email me directly for any additional questions or answers. So with that, again, we're right at the hour. I will just go into a couple of more questions that we've got coming here. And there's one that's been answered online, but he's asked it a couple of times. So Joel, I do want to throw this one out to you.
Yep.
Is it possible to communicate both edition 1 IED and edition 2.1 IEDs using one SCD file for all different versions? Or do they have to create different SCD files and clients for each edition?
So this is the downgrading I mentioned. It depends on the exact mix of devices in the system. There were some changes to some of the CDCs through edition 1 and edition 2, and so you do have to be careful. All the devices that need to communicate that information need to be able to understand the same set of data objects. There's actually only a couple of cases where there's a significant difference there. So if your system doesn't need those particular data objects that changed, then there's no problem. There's a mapping for the couple of cases that can make that work across that. And then the system configuration tool needs to be able to understand the revision level of each of the devices. Each of the devices in the SCD file has its own IED section, and so it gets configured appropriately. Then depending on what the devices in the system can interpret as far as the SCD file themselves, in some cases the SCT has to publish, for instance, an edition 1 SCD file and an edition 2 SCD file of the same system. Remember, these SCL is an exchange format for files. The system configuration tool manages the database of all the information. So if devices can only consume one schema or the other, the SCT can produce the versions of that file needed for each of the devices in the system. So it depends. There are a few corner cases that have to be managed carefully, but in general, it all works just fine.
Okay. Next question, and you did kind of touch on this in the presentation, but it came in kind of in the last couple of minutes, so it might be good to elaborate on this a little bit more. Is the Test Suite Pro capable for client testing?
Test Suite Pro is a test client, so it's designed for testing servers and publishers. DTM is the server simulator primarily. DTM does client functionality as well, but it's primarily the server simulator. So if you're looking at testing a client, testing an HMI, testing a gateway for the client side, then DTM is the tool to simulate the number of devices you need to exercise the client.
Okay. Kind of another question along the lines with Test Suite Pro. You had again answered this earlier, DTM, and how many IEDs DTM can simulate. This question is coming in saying, how many IEDs can Test Suite Pro simulate?
Test Suite Pro has a simulator. It's designed to simulate 1 or 2 IEDs. In a lot of ways to exercise Test Suite Pro itself, but sometimes there's a need to simulate an IED, so we allow that in the tool. I mean, it's not at all designed to simulate numbers of IEDs. That's functionality for DTM.
Okay. I'm going to go back to a couple of questions that came in a little earlier, so this might be more on the content you addressed in the beginning. Is there any compatibility issues with edition 1 and edition 2? And does edition 2 still support edition 1?
Yes. Again, the tissue process I went over was very active in Edition 1. Edition 1, 61850 was largely invented out of whole cloth to meet the needs of this industry. And so there were a lot of revisions over the lifetime of Edition 1. To some extent, Edition 2 collected a lot of those tissues. So it's more, the question is actually more when in Edition 1 a device was produced. Early Edition 1 device is very different from Edition 2. A late Edition 1 device is hardly different at all because those tissues were applied over that life cycle. I strongly recommend against any new development of Edition 1 systems, but except it gets a little more complicated with some of those early devices. There are some systems in the field like that, but other than that, compatibility is possible. But there are some issues to work through to make that all work. Again, that's the reason we went through the effort we did to identify any problems going forward.
Okay, next question. Is there a security recommendation for GOOSE traffic when it is leaving the substation with our GOOSE?
Yes, there is. Our GOOSE includes encryption and authentication. We're currently working on a implementation of Key Distribution Center GDOI client that works with a GDOI server to manage all those keys. It's an interesting problem when you're securing multicast traffic across a network, across multiple networks. But absolutely, encryption and authentication is defined in the standard and is coming to the market very quickly. We'll have a webinar about that coming up, as a matter of fact.
Okay, next question. Can DTM handle a collection of CIDs rather than a single SCD file?
Absolutely, DTM can import any combination of the above.
Okay, next question. At some point in the future, will the SCADA be seen as another application using IEC 61850, or will it continue to be seen as separate functionality?
So that's an interesting question. I mean, there's definitely a lot of SCADA using 61850 now. The channel from the substation to the communication center is slowly migrating. We've got a couple of technical reports. One's in the process of being revised and moved from a technical report, which I mentioned earlier, to a technical standard for substation and control center communications. So yes, it's entirely possible to run the complete network up to the SCADA system with 61850.
Okay, well, I think that covers all our questions. So again, I'd like to thank everyone for taking the time to come and join us for this topic and ask as many good questions as you did. I appreciate if you answered the survey that you get once you sign off from here. And certainly, please feel free to reach out to us directly if you have any additional questions. Thanks, Joel. Thanks, everyone.
Thank you very much. Good day.